This is assignment 17, question 80. And in this case here, I'm talking about the formation of ozone from O2. So here I've written out the balanced chemical equation for this. And the first part asks you whether the formation is favored at all temperature, no temperature, high temperature, or low temperature. We have to find out kind of what the state is regarding the delta H and the delta S. Delta G in general at different temperatures. It's going to be spontaneous or not. So we need to find delta H and delta S for this reaction. So remember, delta H you're going to find, you have to go to tables. Okay? So you're going to find this from delta H naught of formation values. So delta H naught of this reaction, it's going to be delta H naught of formation of products minus reactants. The reactant, O2 in its standard state, this should just be 0. The delta H of this guy here, we're going to have 2 of them. Delta H naught of formation of O3, this is going to be the entire equation. So this is going to be 2 times 143. So you end up with 286 kilojoules per mole. In that case right there. It's actually kilojoules for this reaction, the way it is written. Okay, let's just erase that per mole because there's our 2 moles right there. 286 kilojoules. Go ahead and also find delta S naught of the reaction. Now this doesn't use delta S naught of formation values. It uses absolute entropy values for a specific compound or a specific species. In this case here, elemental species and their standard states are not 0. People run into this problem a lot, and for some reason, it sucks people in and you forget all about that one. So this is going to be equal to 2 times our absolute entropy of ozone minus 3 times our absolute entropy of O2. So you can find those in the tables, and you end up with a value of minus 137, and that's joules per Kelvin for this equation. Now, just looking at this, remember your equation for delta G equals delta H minus T delta S. And for a reaction to be spontaneous, delta G has to be negative. If my delta H is positive, it is, my delta S is negative. This means that at all times, doesn't matter what the temperature is, delta G will be positive. So this reaction here is not favored at any temperature. So no T is the answer for that case there. Now B asks you to actually calculate delta G naught for the reaction at 298. So you have to take your values of delta H, delta S, and you're going to take your temperature, which is going to be 298. Only thing to watch out for is your units. Delta S is in joules, delta H is in kilojoules. So make sure you switch one or the other of them to make sure that at the end you have the correct number. So if you write all this out, you end up with 327 kilojoules. Now this is for this reaction the way it's written, but the question is asking for the formation of ozone. So this is for the formation of ozone. You're going to have to assume 1 mole then. Okay? So this is kilojoules per 2 moles of ozone. So the actual answer is going to be 163.5 kilojoules per mole. And the last part now, I want you to find delta G at 298, where we're not at equilibrium. We have different concentrations now of the 2 different species up here. I'm going to solve it. So remember your equation. Delta G equals delta G naught plus RT ln Q. In this case here, our Q is going to be equal to products over reactants. We're not concentrations, we have to do partial pressures. So the partial pressure of O3 squared, that's where our stoichiometric coefficient shows up, over the partial pressure of O2 cubed. So we can work all this out. We know now what Q is. You're given these guys in bars, which is the proper format you should have. So you have both of those numbers. Your temperature is going to be 298. Your gas constant 8.314. That's joules. Remember this value here, though, you have in kilojoules. So just be careful here. Switch this down to joules or that up to kilojoules, however you want to do that. And you're going to end up with a value of, what is that number here? 100 kilojoules per mole. There you go.